Alright, so hi guys, welcome. Today we'll be talking about complements, disjoint events, and the addition, well, more specifically, the specific addition rule. Okay, so first off, I want to start off with a pretty cool little rule, and it's actually law. It's Benford's law, which was first mentioned in 1881 by the astronomer Simon Newcomb. And this states that if we randomly select a number from a table of physical constants or statistical data, the probability that the first digit will be a 1 is about 0.301 rather than zero point 0.1 as we might expect if all digits were equally likely. Okay, and here's the actual formula for it, where D is the first digit. So if you wanted to predict where, let's say 3 is the first digit, you would put it into here and calculate it, and you would actually be able to find it. And so a lot of cool stuff with this. I'm not going to lie. This is really unique. It's one of the most strangest laws that you'll ever see, because if you it, I mean, it's one of the weirdest things because, if you think about it, it just, well, and actually I've seen a video on this, and it's on a number file, a great website that talks about all this stuff. But they actually say, well, you go from 10 to 19, and that's 10 numbers, and then all the other numbers are just catching up. So 10 through 19, if you only have a list of data from 0 to 30, 10 through 19, you're already almost at 30%, 33%. Okay? And then if you keep going up, well, no, 1, 2, 20s. Yeah, so that's 33%. And then once you keep increasing the numbers, it goes, the 33% will go down. And then once you get to 100, you got 100 through 199, and then from then on out, that percentage is really high of all the total numbers. And then the percentage goes down because you're now in the 200s, you're now in the 300s, you're now in the 400s. So that percentage goes down, and then it jumps up when you get to the thousands. So because one is happening first, that's why this percentage shows up. It's one of the most unique percentages, and it's really, really, really cool how it works. Okay, rules of probability that we'll need to know. All right, the specific addition rule is for mutually exclusive events, which just are two events that can happen at the same time. So when you see the probability of A or B, you're going to take the probability of A and add it with the probability of B. Voila, that's the simple way about it. Now, disjoint events are also, the probability of A and B happening. So like, for example, when you're rolling dice, the probability of rolling a 3 and a 4 at the same time are just impossible. So that would be a disjoint event. Okay, so complements. Let's start talking about this. A is the event, and A prime is the complement of A. And A prime is all the outcomes that are not event A. So the probability of A is plus the probability of the complement of A is always going to be equal to 1. Now we can use that knowledge to find the probability of A. So sometimes it's easier to find the complement of the probability of A, and then we can actually use that to find the probability of A. Like, for example, this formula right here, the probability of A is equal to 1 minus the probability of the complement of A. Okay, so let me give you some examples. Okay, so the probability of, let's say you were looking at, and this would be the sample space, let me see, rolling a 2, okay, the complement would be 1, 3, 4, 5, and 6. So the probability of rolling a 2 would be equal to 1 minus the probability of rolling a 1, 3, 4, 5, or 6. Oh, let's get rid of that. I'm not going to write like message board speak. So you could actually find the probability that way. This one is actually really easy. This is 1 out of 6. Okay. Now this probability is going to be 1 out of 6. This probability is going to be 5 out of 6, and 1 minus 5 out of 6 is 1/6. But this is just how it works. It's all set up like this. Okay. So if we wanted to find the probability, let's say not getting a king when you draw out not getting a king or a queen. Okay. All right, so this would be equal to the probability, 1 minus the probability of everything else but king and queen. Okay? All right, so that's pretty much how complements work. There's a lot of great work on it, but just remember, if you just go 1 minus it and for the complement, it just makes your job a whole lot easier. Okay, so list both the actual events you're looking for and the complement of those events, and it just makes your job a whole lot easier. Okay, all right, that's it for today. We'll talk to you later.